Hi,
Okay.
and
Yeah.
welcome to the Digital Health Hackers podcast. Today I have Christian with me, who is probably a very well known figure in the openEHR space, and he has been one of the major authors of the first openEHR implementation, etherCIS, and he is joining us from Switzerland today. So, Christian, hi, welcome to the podcast.
Thanks, Sidharth. Yeah, I'm Christian Chevalet. I'm originally from Switzerland, and I moved 20 years ago to the Asia Pacific rim, first Australia, and then since 15 years in Thailand. So today I really enjoy the massive drop in temperature compared to my normal life. And I can see you wear a t-shirt. I wear a shirt today, but normally I wear a big jumper. So it's really interesting. Yeah, so born and raised in Geneva, Switzerland. I started actually to get interested by electronic and study physics and computer science in Geneva. And at that time, I moved really quickly on working on the various projects, big systems, and so on. It's just actually quite important. I just give you some background about what I am doing because I'm really coming from the mainframe slash Unix system. And I always struggle actually with Microsoft for tons of reasons. I could write a book actually about that, but basically I have this big orientation about centralized and then decentralized distributed system. And long story made short, I'm really a very much backend guy. I've always been interested by what is happening in the data center. When I go into the data center, I feel it's really exciting. There is a lot of noise, and it's another world, really, light, and so on and so on. So I've been working 10 years for the financial world, where unlike healthcare IT, there is a lot of money. There are very short decision cycles, so you can try very quickly new technologies, and they invest a hell of a lot just to remain competitive. I think this perspective is interesting, though, because you find out what are the drivers for information system. And since it's money driven, then they invest money because it's business critical. And in our scenario here in healthcare, it's completely different, really. And sometimes I also struggle figuring out actually how we can push uh, for the adoption of information system and finding incentives and so on and so on. But you know the problem anyway.
Yeah. I mean, I think a lot of viewers today will probably understand this problem in depth. And
Mm.
definitely, a lot of people come from either banking or telecom. And once they get into
Yeah,
healthcare, they just look at the complexity and they look at the speed at which decisions are made. And they're like, what's going on here? Something is wrong,
yeah.
you know?
Yeah. So after that, I felt as software developers, we were reinventing the wheel when it was coming down to networking and operating system and so on and so on. So I was really, since my driver is really, I want to cover almost everything in the computing world. So I wanted to work really more into the hardcore barebone system environment. So I worked for Sun Microsystems, and yeah, like you mentioned, uh, doing large deployment architecture for telco and ERPs and so on, and which was really interesting because you are facing really true operating issues and figuring out actually how you make your system secure and reliable and easy to configure, deploy, and monitoring, and so on and so on. Still in the Unix environment, of course.
Right, right, right.
And then
So,
I also had some very strong interest about the healthcare environment for various reasons, being exposed, especially with backend systems and so on. And I had an opportunity to move to Australia to work on the medical devices for aged care, post-acute care, long-term care, and all this monitored, managed environment for long-term care patients.
mhm,
And that was really very, very insightful in the sense that, especially when it comes to dementia care and these kind of things, and how you deal with that, how you aggregate all this sensor information, how you connect that to the care team, and so on and so on. But I would say that is really important because for me, as as a human being, actually, I've been working quite a bit in those facilities, aged care facilities, and so on. And I saw actually, well, of course, the stress and the burden of care team, but as well as what is actually going on for the patient and so on, and what the residents actually, to put it nicely, the way they are called. And after this time, I figured out what was really important was the point of care. What's going on actually at the point of care? And well, a lot of things is really pedestrian when it comes to it, and the lack of proper information or consolidated information about the patient status and so on and so on. And going back to the incentive, I also discovered at that time that in the US, especially, I was working for a larger aged care institution in Atlanta. And for some reason, since my background is backend system and database, I said, well, okay, how about actually we put a database into that system to log and to have a journal of what's going on for the patient. And, and I think that's an interesting reflection. They found it absolutely great, but not for the reason I expected. They found it absolutely great because they could actually monitor the financial cost of each patient,
mm.
and they could adjust the premium because they were as well an insurance company. So that was actually the magnificent of this database implementation, was actually to help them to do their financial adjustments.
Comes back to the money always. Yeah,
Yeah, exactly. Follow the money trail.
yeah, yeah.
Yeah. And then I was really quite keen on continuing around the point of care, and I had a call from a friend who asked me if I could build up a system to replace an existing centralized monolithical information system for ophthalmologists. And Unix, Linux, open source, and so on. So I was really looking around GNU Health, what is Patient OS, which is
And
rebranded in
and
Thailand as
what
Hospital
year
OS.
is this? Do you remember?
Yeah, it's in 2004,
2004.
something
Okay,
like that.
okay, okay. Yeah, 20 years ago.
So I've been looking around that, but these platforms, they are very well designed around dealing with forms. SOAP and subjective, objective, and so on and so on. And they are very much focusing on dealing with forms and so on, but not so much about reusing the data, and well, interoperability is totally out of context, and it's basically quite simplistic system. While I was dealing with ophthalmologist, and I'm an IT guy, so I have a very naive perspective about how difficult it is to implement a clinical information system. That you know as well, right? We oversimplify it and then we discover, oh gosh, okay. And how about actually we want to add this type of information, or we want to have actually an automated screening, and how about this, and so on and so on. So basically, the more you dig into this problem, the more complex it gets, right?
Right.
And if you do that with a traditional approach, well, you go through all this maintenance, modification, so on and so on. It's very complex. So I felt very quickly that this existing software were not applicable. By the way, actually, they were using a system coming from Siemens, and it was the same problem. It was very expensive to maintain, add new forms. And since it was based on Adobe form architecture, it was really harder to do anything from the storage, actually. You couldn't do anything, basically. So, digging, more exploring this domain, still in 2004, 2000. I came, sorry, that was in 2010. So I skipped 6 years. So what has happened, I came across openEHR, openEHR. So being through the specification, I felt at the beginning that this stuff is really, really hard to implement. It's daunting. And to be honest, I felt it was impossible to implement. I told that to David Ingram, by the way.
Right,
I
right.
said, oh my gosh, it's just, it's too much, right? Yes, you want to say something?
No, no, no. I agree too. I think this is at the time where there was no other open source implementation. So, like, you are kind of just looking at the spec. And I'm assuming there was the only commercial implementation was Ocean, maybe better. I don't even know. Were they around at that time?
Yeah, sure.
Yeah, yeah.
Yeah, well, oh no, at that time, actually, when it was coming to open source, 2011, I don't think actually, yeah, absolutely. I need to mention, I came across libraries from
Okay.
Rongchen, from Sheriff,
Hmm.
from Corey, and I found that very inspiring for what we were doing. But we were going through, with my team, we were going through some very interesting experiment regarding how we could implement that. And we try obviously different scenario, including using MUMS-like system, inter-systems cache, and XML database. Then we try object-based database. Uh, yeah, and it was really frustrating because I couldn't get anything positive coming from that. We wasted a lot of money, and it was very, very frustrating and costly at the end. So long story made short, few years after, I was not really convinced by what we've been implemented, and I'm not really happy when it comes to storing blobs in DB, and I will come back to that. So at one stage, I was very keen on following what was going on the database front, and especially Postgres, because that's what I was using also for many years before. And they were coming actually very nicely with some better implementation to deal with no SQL data types, especially JSON. because our experience regarding XML was terrible, to be honest. It was not really usable. It was really, really slow. But what this guy in Russia were doing, Oleg Bartunov and so on, for astrophysics, I think they were implementing that, and it was really quite cool, in fact, with very nice indexing and these kind of things. So I said, okay. One day I decided to completely change the orientation of what we've done so far, and we implemented with a NoSQL inside SQL perspective. And I would say this is my driving my motivation since that year. I didn't really move outside that, and I would say fortunately, because we'll come back to the progress of database and so on, it's quite stunning what is happening now at this level. Anyway, so that was the premises to implement etherCIS. Taking the openEHR reference model and really working on that to find the right, or what I thought what was the right way to implement a storage based on that. And that's what I've been doing since, actually. So that means that about 15 years of implementing reference model into a database system. So etherCIS came out, then the guys from openEHR, I've been in touch with the guys from openEHR, especially Ian McNichol. So thanks, Ian. He has been so instrumental in this development, I would say. So implementing AQL, then some REST front-ends, kind of things to make it acceptable for user interface developers, these kind of things.
Got it. Just a quick question, right?
That was,
I think just a quick question. I think so. You mentioned about the databases, especially Postgres, coming out with JSON-B, right, and then that making it much easier for you to do new things. Did you ever consider other NoSQL solutions at that time? For example, I think MongoDB was also coming around that time, and right now we have a lot more options. What was your opinion on Postgres, JSON-B versus these other NoSQL first solutions?
Yeah. Okay. I've been using, I mentioned before, I've been using InterSystems Cache.
Cache. Okay.
Yeah, Cache, because it's supposed to be a very enterprise implementation of NoSQL. It's not dealing really on the JSON document, but it's dealing with hash maps, maps of maps. And it's a very attractive option when you implement the reference model, really. But there is always a big but. The thing is how we map this NoSQL information model into the software Java, basically. And then actually things getting really, really difficult because what was really announced was not really working.
Mm.
So we had a lot of exchange with the labs trying to get support and so on. And at the end of the day, you have to also realize that a platform like Cache is a very expensive option.
Yeah. I mean, Epic probably pays half of their profits just to Cache, and I mean, it's interesting.
That's true. It's really expensive. So even if you develop, there are, and I had arguments really with the sales team. If you want to develop, you have to pay anyway. or you had to, but maybe they changed it. But well, since then yes, you're right. There is MongoDB. MongoDB is another. At that time, actually, the other issue was about in terms of their approach, the perspective regarding the reliability of the storage. It was not that really convincing, to put it nicely.
Okay.
So I think it was a risky option. Then yes, there are tons of other options regarding DB4O. That's what we have been using, but DB4O again was really, it was not mature enough, I would say, to go into this path. Graph database. Uh, it just add to the complexity, and this is a totally different world in terms of query language, formalism, these kind of things. And I was really very concerned. Oh yeah, yeah. Very importantly, I was very concerned about the privacy and the security of the data
Okay.
because I've been through an exercise about the certification for compliance to the security privacy regulation for a clinical data system. And you have to really tick a lot of boxes really to get approved now. So you have, and that is actually a very important perspective when you implement such a system because you have to comply. It's not actually you just do it and yeah, oh, we can add security later on and so on. Well, it's not really working that way.
Right.
And you have a lot of potential breach. If you remember, for example, Sing Health in Singapore, the way they have been hacked was not because the system was exposed to hackers from the outside. It's actually the system was exposed by insiders, people working on the system. So it makes really the complexity of all that. And it goes to how you do backup. Thanks to my 10 years experience in data centers and so on, it's another very important topic and how you deal with upgrades, changes and so on. So I thought actually there are different options regarding what I was doing. It was basically Postgres, DB2 at that time had the JSON implementation, Oracle, and since I wanted to do something really open source from A to Z, Postgres was the natural option, was the standard option, I would say. And
Okay.
really, to be honest, I don't
Yeah.
want to deal with experimental database implementation, whatever actually. This system are fueled by venture capital and so on, and it's always nice and rosy, everything is smooth and so on, but yeah, but the reality is quite different, really.
Yeah, so I mean, you went with Postgres, and I think that decision has now led to almost a lot of people in the open space picking Postgres as their, like their
Yeah,
default backend, or even these new Postgres implementations like Yugabyte, Citus, and all of this.
yes,
So you
yeah,
so what you built was etherCIS at that time, right? So tell me the story,
yeah.
like what happened after you built this, and did you what led you to build this? Was this just you sitting in your space building this? Was it another team, or how did you start building this, and what happened?
No, I wrote it because I was so upset by the previous experience. I would say, okay, if I, very honestly, it's like actually mountain climbing. It's just, you feel, gosh, if I cannot do that, well, I really fail. I'm a failure. It's better actually. I go to do some goat cheese somewhere in the mountain. I'm not kidding you. Actually, it was really my opinion. I spent all these years developing, implementing, deploying systems and so on, and I'm not able to do that. What's wrong with me? So I really wanted actually to get that to get over that. It was really a personal challenge.
to solve healthcare or to solve the healthcare data challenge?
Yeah, to me, it was really a technical challenge. And after all these years, I had to do it and to leave something. I had also, yeah, you're right. I had also the feeling that I was doing something useful. So yeah, that was really my thought at that time. Then
Excellent. Yeah, excellent. So tell me, so you put out etherCIS out in the open, right? And did you actually try it out? What was the first site maybe where you tried this out in production? And how
yeah,
did you what changed? Did anything change from what it was before?
yeah. I've been contacted by Tony Shannon from the Ripple Foundation, and they had this project in Leeds for the personal health record. So we worked together to do that deployment out there with the NHS people on sites and so on. And yeah, then there are a lot of political things happening within the NHS and so on. For some reason, actually, I think it's beyond actually my understanding, but for some reason, this project has been passed on to another team. And that was it, actually. I don't know after that where things have been heading and so on. Then that was now we are in 2018. I've been in touch with the guy from Vita, and we had a meeting in London at that time to figure out how to use etherCIS to staff it up with more people and to move to the next step. Because before that, it was really a one-man show, technically. It was me and voila. So, and I think I was also not very happy about that because there is a very high risk. For example, I'm going to do some ski or scuba diving, and then I have an accident, and that's it. It's the end of it, basically.
Yeah, I mean, the most
Even if it's
extreme,
open source.
right? I mean, again, like all open source projects, without the team, I think the source code itself, there is no real value. Like you need them to drive it. And okay, so you were
Yeah,
contacted by Vita Group at this point, and I think this is the same time in which HIMED had contracted them to build Airbase, as it would later be called.
yeah. So it was a joint venture with the Hanover Medical School and and Vita Group. That was 2018. So I've done some, in the meantime, we were actually moving with this Airbase ID, which really started in 2019. So things really, is getting interesting because it's like in Terminator, yeah, the storm is coming. So, so basically, I've done some work, very interesting thing at Maastricht University for a predictive analytics project in the oncology department. But that was also a spin-off of UMC at that time. But what was really interesting, it was really another dimension regarding how to integrate analytics into the overall picture. And this project was very interesting. Well, actually, it has been terminated, but it's more actually related to some personal problems with some people actually who left totally and went on to something else. Anyway, 2019, we started actually to go for this Airbase implementation, and then the storm was there, COVID.
Got it.
Which was, in fact, Sidharth, when you think about it, it was a very interesting time for what we were doing because people were really concerned about having the right clinical information for very good reasons. And it was very, very nice because it gives us a lot of well, we were really riding on the wave, and we were really surfing on it. It was really cool, I would say. A lot of possibilities, and it gives a lot of relevance into what we were doing.
Right. So, what do you think changed at this time, right? Like, why did people start caring more about how healthcare data was stored? Do you see anything maybe in the regulation or something that kind of shifted at this time?
Yeah. I think, well, for us, basically, first of all, having an interoperable platform was really critical because for analytics purpose, you could actually have standalone system and go the usual way to exploit the information base, basically. So that
Right.
was really one of the big change.
And this is the Maastricht oncology platform that you're talking about.
No, this is really HIMED.
HIMID. Okay, HIMID in general. Got it.
Yeah, yeah. No, I'm really going into the COVID time. So COVID time, 3 years.
Got it. Got it. Got
Yeah,
it. So COVID, yes, COVID. So COVID as an enabler for the data platforms. Okay, got it.
yeah, that's right. I think when we were talking, I think when during the discussion when I was talking about incentive, the incentive was there. We need the data. Well, that's actually the way I understand it for various purpose, right? But that was really one thing. Then we actually also in the meantime, FHIR was coming very strong, right? Uh, so we had this very interesting time where we could really focus on implementing things, and we had the support to make things working. And again, I was really thinking that post-COVID, things would remain the same. No, it didn't actually. We are not learning anything.
I mean, yeah, I agree. During COVID, there was this peak in interest in all like digital technologies, and then like it just went back to how it was. Yeah.
Yeah, it's amazing, right? We are waiting for the next wave, or I don't know actually, but we are learning nothing.
Hmm.
So, well, it's always the same thing. There are a lot of financial interest into the healthcare environment as well. We cannot escape that, right? So, nevertheless, it was a very, very good experience and a very good project to move etherCIS to this one-man show, as I said, to something more enterprise level and refactoring, changing things more in a perspective of integrating more people and so on and so on. Well, it was good. Then after that, I've done a quick project on working on a very different information model, very close to, well, it's actually FHIR, in fact,
Okay.
using how we can deal with FHIR information model with a lot of possibilities regarding querying it. Because it's a protocol basically. FHIR is coming from HL7, and the main purpose is actually to convey information for for billing and this kind of things at the root of HL7. And the information model is very flat compared to openEHR. The semantic is dealt with very differently, I would say. If you take if you take, for example, things like blood pressure, in an open-air environment, we have the context, and the context give you really the ontology and whether the blood pressure is measured at home or is measured in the clinic and so on. But for FHIR, you have to link it with the terminology to get that same information. But I think this is changing maybe. Anyway, so I really injected the FHIR information model into a property graph. And because I think I was also monitoring what was happening on the database front, but it was not yet available. So I implemented a property graph within Postgres to be able to see how it was performing and so on. And I would say actually, if you do it not with a pure graph, but with a property graph, the performance are really quite stunning in terms of indexing and so on. But now we have openEHR, and we have a way to query openEHR to deal with the data with a language, SQL. And on the other hand, you have FHIR, a different information model, and you deal with the data with a potentially different query language. Now we are talking even about SQL on FHIR. And then you have all this constellation of legacy data that also you tackle with a different language. And whatever we think, and the hospitals I'm working with in Thailand, they have a lot, they're like everybody else actually, they have a lot of different EHRs within their premises and different formats, different standards. And of course, everybody is talking about FHIR, but FHIR is a very, I would say, a tiny part of the information models we have. Basically, this different data sets, different data repositories, they are here to stay for quite a while. So what we're gonna do there, we just go and say, well, we are sorry, now you unplug everything, and here is your brand new openEHR system. Good luck. My personal experience with that, and there are a lot of politics inside hospitals as well. And people are not that keen to change anyway, especially they will not change on a snap, right?
Right.
How we deal with that now?
So this is where your new invention comes in.
Yes, that's where my new perspective is
Okay.
coming in. The database system we have, especially, I love Postgres because Postgres is like Linux. It has tons and tons of extensible potential, scalability, and so on and so on. And now we have I think JSON has been integrated as a standard in 2000. I think it's 2016 actually. So if you
In
follow,
in
if you
Postgres or in
follow
ANSI SQL?
exactly ANSI SQL, yeah,
Okay.
ISO,
Okay.
yeah.
Got it.
I think it's ISO 2016, and then keep on going. Now ISO to 2023, we have Cypher, we have graphs. Now, and that is actually, I'm just mentioning two, but we have a lot of other capabilities at database level. So basically, we have a way to federate a lot of diverse information model in the same database. Plus, we have, well, we know that with Yogabyte DB, and I also explored Citus before. We have a way to distribute the information, and we can distribute the computing power, the processing power of the database engine to multi-nodes, and each node is being specialized into its specific information model using a pattern to access the data and so on and so on. So why not actually architecting the data storage based on all these available components we have. Well, it makes things really simpler in a way because we don't need that much mapping because we have specialized components. All we need to do in a way, it's like grid computing. We need to have all these distributed agents working specialized on this type of data and so on, because we know what we want to query anyway. It's not anything, or give me anything. No, we don't do that. We want to have the vitals, and we want to build an IPS, an international patient summary, or we want to have the prompts and so on and so on. But we know what we do. We want to combine this query, this clinical data with demographics or with geographical data. For example, you want to study the impact of a Bhopal type of incident, and you want to analyze that on a clinical standpoint. So you have actually to deal with all these different type of information. Now, today, the database is giving us a lot about that without doing that into the client. And why is it important? Because we can optimize the querying at database level, and we have the tools to do that. So it helps us to do a lot of things, really. And we can test it separately.
Right. So here, so according to you, you're saying these different data sources remain in these different databases, both in the database technology as well as physically, they remain in different places. But we kind of need like a query tool that will go to these different databases and then get the results, combine them, and do this federated query, right?
Yeah. Now you ask me, what is the query tool?
Yeah, sure. Postgres.
Yeah, well, the query tool is SQL, but it's not a plain SQL. I don't write SQL statement for many years. I write SQL with a level of abstraction, and this level of abstraction is within the Java framework is Juke. So we have this Java object-oriented query. Now, what I've done, that's what I'm working on. I've extended this the Juke libraries to have more to simplify the path expression to value points. Now, when it's getting really nice, or in my opinion, when it's getting really interesting, is we are not dealing with data. We are dealing with true objects in the sense that we are not dealing get me this, get me that, but we can do that with a much clever way. Give me the blood pressure, give me the glycemic level, and we can bind that to a semantic level. We can query by ontology code. That's quite tricky, actually, but that's something we are evaluating different scenario, especially when it comes to transitive closure. Actually, I watch. Did you watch the conference from Graham Grave regarding SQL? No, the conference, Graham Grave conference regarding SQL on FHIR, and especially when you mentioned.
Yeah, I think they now have view definitions, and they have a new standard on SQL on FHIR.
Yeah. So basically, the thing is, you should have. You're not interested to, let's say, again, back to blood pressure, you don't interested to have this very long path to tell, oh, that's where I'm accessing the value point. Because most of the time, actually, you just need to know the name of the value point or to know the terminology code of the value point. That's all you need to know. The system, that's why we use computer, by the way, is to make our life easier, right? So now we want to do that, and to do that, we can have a query engine with a high level of abstraction that actually deal with all this simplification for you. And it's not AI, by the way. It's really it's it's simple algorithm actually. So
Yeah, I mean, I think an example would probably help. I think I saw a few examples in the paper that you shared with me, and I think you have slides as well.
yeah,
Like just to
yeah,
like illustrate the concept a little bit more and what we are doing. Maybe you can share your deck.
yeah, I will do that. Yeah. I just wanted to say something regarding the query engine. This is really it's really components based. It doesn't have any opinion. It's not opinionated regarding the interface and so on. But I think there is a strong separation of concern between the way you implement the different query level and the way you use the query itself. So yeah, I will give you an example. Let me do that.
And this reminds me to some extent of, so we use Postgres quite a lot in our company as well. And uh, we usually have a rule stating that if you can do it with Postgres, you should try to do it with Postgres first. And only like when it fails, you try to do it with something else. And
Yeah,
we had an instance where we had like some data of this hospital was in a MySQL table. And we had this discussion between like, okay, what do we do now? Do we like take a copy of this data and then put it here and then query on it in Postgres? Or then we just found out that Postgres had this feature where it can technically connect to a MySQL database while keeping the data in MySQL. And you can kind of just write a query that can query on a foreign database. And
yes,
that to me was, I'm not sure what that feature exactly is called, like maybe foreign tables or something, but you can kind of
it's for data wrappers. Yeah.
foreign data wrappers. Yes, yes. And that was not limited to just MySQL. Like you can write your own foreign data wrappers for CSV, for S3, for like, there's a bunch of stuff. And I was,
Exactly. It's an amazing feature. This is really where the Linux of database is coming. This is totally stunning. Not only that, actually, you can optimize the query at the agent of that foreign data wrapper.
mm,
So when you post, sorry for the REST expression, it's not REST now, by the way. When you post the query, the select, or whatever, it's not limited to select, actually, it's any SQL statement. But the remote agent will optimize the query for you, in fact. So you can filter, you can do a where statement. Yeah, what I wanted to go, why it's different when it comes to real objects. Let's say, for example, you compare quantities. Quantities in openEHR, the, 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 the reference information model I'm using is openEHR because I think this one is really rich and very well thought about. And I really stick to that. This is really my reference for everything I'm doing. So now, when you want to compare, for example, quantities, you don't compare only values, numerical values, but it's a value on a unit.
right.
And that is really important because actually, otherwise, if the units are different between these two value points, which you can, in fact, you have options, right? So basically, if you filter, you have to filter out inside the client, not at the database level, if you do only numerical value. It's obviously very trivial when it comes to uh, temporal values, date and time, duration. It's another example. So that's why I'm going to, we are not dealing with what we call anemic objects with getter and setter. This object should be able actually to be comparable between themselves regarding units and so on and so on. So you should be completely transparent when you do it, and that's the responsibility of the implementation to deal with that. So we have all this polymorphic stuff and so on and so on. If we are just dealing with transporting data set, and that's why actually I dislike profoundly DTOs, because it's an anti-pattern. They are not objects, so don't call them data transfer object. Just call it data transfer, and that's it. Okay. But that's very important in my opinion. So DHR in this different approach is not like you know, I mentioned to you, I've been bugged many years with the R in EHR, electronic health record. And record is back in time into COBOL system and so on and so on. So you have to interpret that and you have to deal with it. But no, actually, DHR and Epic actually is not doing EHR at all. It's a system where you do your query and so on, and DHR is giving you the information you need to do this form and these kind of things. Here with the query tool, it's the same thing. We have actually the HR through DSL, domain-specific language that tackle actually the complexity for you. That's the idea, and I will illustrate that.
Yeah. No, makes sense. And when you said like Epic is really not an EHR, so do you consider Cache here as an EHR that Epic happens to use?
Sorry?
So you said like Epic is not really an EHR,
Yeah.
right? So what would you
No.
consider? What is an EHR?
Yeah. Well, Epic is it's like Cerner, it's like Siemens, it's like this monolithical information system. It's actually a set of features that you access through a specific modus operandi. And it's like actually dealing with Microsoft platform to do exchanging message and so on. It's actually it's not really an EHR in the sense that we are doing or building it. It's a tricky question, Sidharth, when you think about
Right.
it.
I mean, I think the definition maybe then should be like health data platforms is what people are calling it now, which is like, okay, it's a component that is open and you can query
Yeah.
it and you can get all the data out of it and you use it to build what you want. And, in that sense, Epic definitely does not qualify as a health data platform in any meaningful definition, for sure. Yeah.
That's right. So let me share my screen.
Yes. Go ahead.
I borrowed this slide from Judong Lu in Hangzhou, and I think it's very nice way to put it. When we are dealing with an open platform, and I think it contains everything I'm thinking about. It's an open extensible information platform. And you have different use case, different type of users, different perspective in terms of connectivity. And behind that, into the backend, you have all sort of data, representation, projection, and so on and so on. But basically, on a client perspective, you're just concerned about a unified way to access all this information. And it's no concern to you to reassemble that into your specific application, especially when you look at that between a clinician and a patient. Obviously, none of them actually will spend time to consolidate the information, while they shouldn't actually consolidate the information for their specific need. It should be the same. So that's where really I'm going to. Oh yeah. So I will skip some stuff. Okay.
No. I like that. I like that previous graph that you had, where you had openEHR, and then after that you had like graph-based structures. That's pretty nice. Like, what was the
Yeah.
the evolution of EHRs, I guess?
No, not really. I just wanted to tell something. I got this slide from another presentation coming from the Asian e-health information network, I think. And yeah, the thing is, we when we deal with complexity, and it's like water, right? We try to find the path of least resistance. And here, openEHR is always introduced as a very complex specification, in fact. And I'm sure you know that. And sure, a lot of people are going to FHIR because they have this impression that it's much less complex with a similar semantic depth. And in fact, the openEHR, I think we are missing here one approach which makes it very easy to digest, and you don't need that much, in fact. When you look at it, sure, there are a lot of things, a lot of specifications, but what you really need is not that much. Basically, you can just deal with the reference model and base types. And if you're more interested about models, then the archetype object model, but that's really about it, really. All the rest, I would say you could go without it, in fact. And that's what actually I'm advocating now.
Okay.
So we know that. I'm assuming that people are familiar with openEHR, right?
Yeah, 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 for sure, for sure. Yeah.
Okay, so that's actually when you see that, right? When you see the specification, say, "Oh my gosh, I have to go through all that." No, actually, you don't need much. You need much less, right? Even for me, what has been really the difficulty into this new exercise, I was really focusing on the archetype query language. And I'm sure I will actually make some people not so happy. But for me, actually, AQL has had its shining time. It come out from an approach regarding XML and XPath, and it's not even XQuery, actually, it's XPath. And yeah, at that time, it made a lot of sense, but it's quite a while ago, and things have changed really dramatically. And if you go to FHIR, I think it's pretty relevant because FHIR as well is going SQL. So there are a lot of convergence regarding this. And I was I was really bogged down trying to use AQL for everything, but I decided, well, no, actually, we could go beyond that and use a different approach to query data and also to do all sort of manipulation to data through something derived from SQL. I would say when you go through openEHR, you can see that as a tree graph, really. With the way you access the value points through this tree structure. I'm simplifying it, by the way. It's actually multidimensional because we have the temporal aspects as well, the versioning and so on. But basically, when we want to access a value point, we go through this structure. And that's where in SQL, we give the path. We have to give the path to access a value point. And I don't know much actually other system where you need to give the full path of value points in order to access them, really. So I thought at that time that we might have a better way to access value points, simplified way, which is computed by the content itself or by metadata. That in FHIR, when you want to associate the different resources, a very nice way to do it is through a graph, actually, property graph. I think, if I'm not wrong, the FHIR, SQL on FHIR is doing that using proper tables. But when you really do it with property graphs, NoSQL, data structure inside into the graph. It's really neat, actually. It's a very performant way. The problem is, and it goes down to observation, where you have the actual data. You discover that it's not that easy to consolidate that into, let's say, what we have in openEHR. Because openEHR is very consistent when you have an observation, again, about blood pressure, you have all you need. Here, you need to reconcile it.
Hmm.
And then you have all this other data that we mentioned, legacy data and so on. So I saw this one, very nice diagram on discourse, right? The openEHR discourse. And yeah, uh, how we could actually deal with various data sync and reconcile that. Here it's for a form designer. Makes things really tricky, in fact. You have a lot of APIs to deal with different query dialects and things and so on. And all in all, it makes things really very tricky. And when things are tricky, it's error prone. It's hard to maintain. You cannot find the right skills on so on and so on. So basically, you have to integrate different factors, human factors, and so on, and make your exercise very, very difficult, I would say. And it shouldn't be. Oh yeah, that was a more commercial presentation.
No, well, it's a
So
pretty good saying as well.
yeah,
Like change is the most important thing to manage, and like your statement about getting the right skill set, that strikes really true to me. Like if people don't know how to deal with FHIR or openEHR, then if you build a system or FHIR or openEHR, then how are you going to manage change? Yeah.
yeah, well, that's right. And that they shouldn't have to deal with that level of complexity, really. Actually, no, I don't know many people who really are keen to deal with that, given well, people have pressure anyway. They have a lot of things to learn. And we are not talking about, oh yeah, okay, you spend a couple of weeks on the openEHR and then you are up to speed, you are up to scratch, and yeah, you can go with it. No, actually, it takes months. So that's a very heavy
Learning curve.
people management
Mm.
to be able to tackle with that, and and that is only about the specification. Then you have to deal with the implementation on all these different technologies, perspective, and makes things really hard to find the right skills. Huh? Really hard. You know it, I know it. We've been there, done that, right?
Yeah. The next slide.
So say I want to build an international patient summary, so that contains demographics and clinical data, and I have different source of information. So I have to deal with a lot of APIs to get the information I need. It comes from something really simple that my partners in Bangkok asked me how we can combine a query between openEHR and FHIR, because we want to have the demographics from FHIR and we want to have the clinical data from openEHR. Sounds very, very legitimate and very simple, right? So if you want to do that, and that's the way it is done, basically, that's the client has to combine the queries in order to build what they need, to have the query result they need. But as I mentioned before, we have a different approach when it comes to the backend, to the database, to the data architecture, where we can have actually this combination of different information model right from the same query tool. And I will illustrate that with an example with a query itself, where we can actually combine the two information model within the same query, and it's quite simple and transparent for the end user. And for that, it's a few lines really. Any question regarding this one?
I will have a lot of questions once you finish explaining. But my first immediate concern is there is definitely going to be a performance aspect to this as well. Like, it's going to be slower than, for example, it's definitely going to be faster than doing a REST API call on a FHIR server and an openEHR server and then combining it on your client. But is it going to be, is it faster than one database having all the data?
Because you are concerned about lags in query between the different components or the different agents
Right.
and so on?
Right.
No, actually, it's really an infrastructure question when it comes to that. First of all, we don't have a distribution. We don't have to distribute the different agents on the network. The network in the Unix world is a stream, and the stream can be inside the same machine or it can be remote. And if it goes to remote, we have a lot of technologies available for high-speed networking anyway. So unless we do image streaming, video streaming, what we are dealing with are the discrete data element data types. So it's very, very fast, in fact.
Got it.
And I was looking for the word regarding the network lag that is induced by communication. But no, in a Unix world, that is not really an issue.
Got
It
it.
can be, and we know that, for example, if you have let's say, take an extreme example, you have your main server in Bangalore, and you have a remote server in Mumbai, right? It has to go through a lot of hoops to go from your central system to the remote system. And then, yes, sure, definitely, you have it has an impact on your performance. Now, let's say you can replicate, well, you can actually provide a materialized view on your Mumbai system locally. You can cache it locally and synchronize it. Then actually it's much faster. Also, another way, when we are talking about cloud, because people are they say, oh yeah, but we deploy everything in the cloud. But many instances actually, if you look at the capability of the hardware, it's getting really economically very interesting to have a bare metal system with a lot of memory and storage, and you have all that into one platform, and then yes, you have the streaming communication within one system, and that is actually we know how to do that very well now
Got it.
for many years, in fact.
Yeah. So this is one big server which kind of has multiple different distributed clinical, data instances running. Okay, got it.
Yeah, and where it makes a lot of sense, we are addressing important technical aspects by a very strong separation of concerns. When it comes to infrastructure communication, that's one specialty. When it comes to data architecture, that's another specialty, and so on and so on. But each and every one actually are dealing with their specialized work. They can test it, they can optimize it, given actually the specific domain. Like we are doing in a data center, like we are doing when we deploy an ERP and so on. That's very, very much actually a standard enterprise way to deal with the information system.
Got it. Maybe, we can go ahead. We can see a few examples and, like what exactly this entails.
So that's really the architecture for a system like that, where you have to you deal with different components with strong separation of concern, and whether it's a driving component like a REST server, or it's a driven component like a storage. Each and every one is addressed specifically regarding it's tested and implemented specifically regarding its own domain and specification. But you have an orchestrating component in the middle that route the query, the message, in fact, between the component to perform, to fulfill the requirement of your use case. But I will skip that. That's an example like that, right? You wanted to see.
Yep.
So this one is a combined query between a FHIR resource for a demographic resource and well, this one is a bit is even too complicated, really. And an openEHR storage. So we want this is really simplified, but we want to have the body temperature and a list of symbols. And at the same time, we want to have the attribute of the patient. Here is family name and given name. So what is really interesting here, you see, first of all, there is no explicit join in this query. We have two main tables with relation, which are FHIR and composition. Composition is a simplified expression for the openEHR composition content. And we can filter it. Here, actually, it's an overkill for a simple presentation like that, but we can filter it on various properties here, specifically regarding the patient ID.
Got it.
So what is there? The database, first of all, the query language, the DSL, is taking care of the complexity regarding the access path to the various values we want to extract, given name or family name. So for FHIR, it's more like a JSON path, and JSON path is very well documented. A lot of information regarding this. You can test it also locally. And for the openEHR, that's what I put into this extension. We simplify the access path because we know our data, obviously, and we know that we can just access it by the name of the value point, which is here temperature magnitude. There are different ways actually, but that is a more intuitive way to access it. There are some casts and so on, but it's not important to know at the moment.
Got it.
And the filtering, yeah, it's based on the identifier on you have. Actually, this is quite ugly, but that I have simplified it recently. But this is a way to consolidate, or sorry, to filter out based on the patient ID. What is important here, you don't have to deal with joins and so on, because I know people are very reluctant to deal with that, and there are a lot of concerns when it comes to performing joins on the relationship, SQL relationship. Here it's implicit.
Got it. So it implicitly knows that this particular FHIR resources match to this particular EHR ID in openEHR.
Yeah, by this filtering. Yeah.
Got it. Got it.
The where statement.
Right, but the where statement, I still see that is, you're querying on using the FHIR identifier here. So there still needs to be somewhere that defines that this FHIR patient matches this openEHR EHR.
No, sorry, can you say that again?
Yeah, so you have the FHIR patient, right? And here I see that like we are doing FHIR.properties, and then we are filtering by a FHIR identifier for that patient.
Yes, yes.
So, and right now, at least in this query, we are not doing EHR ID based filtering. So we are not doing like composition.ehr ID. I think you've taken that as EHR ID. But my question was, how do you join the FHIR patient object in that FHIR repository with the openEHR EHR ID, which is in the openEHR repository?
Yeah, that's right. It's implicit here. Yeah.
It's implicit. Okay, got it. Okay.
Yeah. You don't need actually to have that. Yeah. You don't need to have that explicitly, because that's where you have in the from statement takes care of that.
Got it. So the system also needs to have some information already, like this is pre-encoded knowledge in the system that it knows that these two relate to one another.
Yeah.
Got it. It's pretty interesting, the new simplified AQL paths, if we would like to call that. It's a very nice replacement over the 80, 001, 002, and so on.
Yeah, because even myself, well, to be honest, I always find it really difficult to code an SQL expression, and I really don't want to have a tool, to have some tool to help me to build the SQL query. I think there is a flow somewhere that, first of all, it's really harder to do the code itself, because it's not intuitive at all. And second, if I need to have another tool yet to do the query expression, the SQL query expression, that makes things really, it's an overkill, I think. It should be way simpler. And that's why actually I have this simplified expression regarding access to a value point.
Mm-hmm.
But if you want to know the SQL expression through the DSL, you can. It will give you the actual expression. If you need, for example, to map such a query, a SQL query, to an SQL query, you can.
Got it. So how does this work? How exactly does this,
How?
Yeah. Like, so I have this query, I have my terminal, I'm executing this query in a terminal. How do you, does this work with the, let's say, an existing openEHR infrastructure or an existing openEHR server and a FHIR server? Or do we need your specific way to, do we need to do something more before this works?
Yeah. Okay. Very good question. Thank you for asking the question. No, it's actually, like as you can see, it needs to have a projection of your existing storage into the format I'm using internally to be able to do that. It's very much like SQL on FHIR, in fact.
Okay. Got it.
SQL on FHIR, there are a lot of JSON manipulation done in the backend. Here it's similar.
Got it.
But storage is cheap today, so that's a good news.
Got it. No, makes sense. For the viewers who don't know about the new SQL on FHIR stuff, so there are these view definition resources which kind of say what part of a FHIR resource maps to what column in a table, and internally the system does a lot of these mappings to then represent it as simple tabular structure that you can run SQL on. So yes, I think we can carry on to the next slides.
Yeah, anyway, today, well, it's like, for example, the discussion I had in Thailand, you have still a lot of clinical data which are not even into an EHR anyway.
Mm.
So I think whatever we are thinking about the state of the art today regarding clinical data storage and so on, still actually we are really at a very early stage. So for me, it was not much concern really to push something like that, where we have another distribution and storage of information as long as it's the same. But I really didn't want to have any translation from one language to another. I didn't want to have any mapping, if feasible, really, except in some scenario, you might need to have some mapping, but mapping, in my experience, is also very questionable because, first of all, it doesn't improve the data at all. And then, well, you must actually lose some semantic of the data as well. And also, it makes the maintenance part very cumbersome and so on. So,
Got it. Makes sense. Makes sense. So let's go deeper. Let's go into the rabbit hole. Let's see what how all of this works together.
yeah. Okay. So when it goes to the foreign data source, that's a representation about the foreign data wrappers. On the front side, the top side, when you access the foreign data, you access it as if it was the primary database. So that's a specificity of the way you declare the foreign data. So once you do that, everything is going into the same query framework and you don't need to specify you access this remote components and so on and so on. It's just plain SQL at the the primary the main um, uh, query engine. Really. Another thing mentioned is the distributed SQL because when it came to this issue about scaling it, we evaluated in Airbase, we evaluate different possibilities. And you know the approach when it comes to large volume, large scale SQL system, you need to do sharding and all these kind of things, which is fine, in fact, in many scenarios. But some other scenario, the sharding, well, first of all, it has an impact on your data structure. You need to have the sharding key, and you need to modify your query accordingly, and so on and so on. Then I have been actually talking to the guys from Yugabyte DB, and I found their model very interesting because the sharding is totally transparent for you. And secondly, unlike other systems, it deals very nicely with the extension you have into your database environment. And well, of course, JSON and other things. But if I want to have more extensions, let's say I want to have, for example, vectors. I want to implement my own LLM inside my database context. Then they deal with that as well, and so on and so on. So I think it's really good. Indexing also is very well dealt with. They have monitoring tools and so on, and it's really performant. They are very good, and it's open source. So cannot complain. It ticks a lot of boxes, really. So this stuff, I think they are in Bangalore as well, no?
Not sure. I'm not sure.
Yeah. But anyway, it's really fantastic what they have done, really. And so this is a very, very good alternative when it comes to distributed SQL. And distributed SQL is very important today now because this we had this issue for many, many years anyway, dealing with a large volume of information in a performant way, and that is actually dealing with it very, very well. So you combine that with foreign data wrappers and so on, and then you have a very, very interesting performant um, database architecture that actually you can tackle any kind of problem. Yeah, another thing, I had another discussion with other people regarding the niceties about SQL, but SQL is Turing complete. So you can, theoretically, you can deal with any problems, any computing problems, just using SQL. You don't need anything else. It is recursive, it has loops, it has control structure, it has, well,
Yeah, yeah. I
everything
mean,
that you would expect into
Postgres
a query language.
Postgres goes even further, and I think there are procedures and functions that you can write in Python and other scripting languages as well. And I
That's true.
think Yugabyte supports that as well because their whole
Okay.
Postgres layer is just the default Postgres implementation. They haven't done anything to it.
Yeah, that's very important what you say, Sidharth, because the thing is, for a lot of developers, it seems to me that the database it's seen as something, it's something we want to avoid. It's something in the dark, and we specifically don't want to deal with that. We want to have a plain abstraction about that. But my approach is completely different. For me, this is really the critical component in the whole system, and everything actually stemming from that.
There is a really famous talk by the creator of Clojure. I think his database was called Datomic, and he talks about like turning the database inside out. I think that's the title of the talk as well. And there are a lot of databases inspired by that, where the architecture of your application determines how you build your database and what you do with your database. So it's a very very similar pattern of approach I see with you as well.
Yeah, it comes from when I mentioned in my personal path that at one stage I found that developers were reinventing the wheel, and I found that again developers re-implementing features that exist into the database, and I think this is maybe potentially a problem of education or something. But the database is not there to annoy you. It's a very powerful tool, and it should be used to the max, really.
I agree. I totally agree. So coming back to this, I saw the slide with the okay, this is a lot more uh, detailed, but you were mentioning foreign data wrappers, and the
Yeah.
Postgres layer being able to query the different the different foreign data sources. So are you looking at this as the architecture from which you can do that previous first query that you wrote? Do you have
Yes.
foreign data sources with like openEHR and FHIR, and then you have foreign data wrappers, and then this the query gets compiled to SQL, and then it runs on Postgres directly?
Yeah. The joke, yeah, the object-oriented SQL DSL is doing exactly that. For you don't need to write, you don't write SQL queries. It's it's totally handled by the DSL. Of course, it is SQL because you see you have select, but you could have also insert or update on whatever. You could have also data definition statement into the same DSL.
Hmm.
Or
Got it.
you could declare index, and that is actually another very important point. Anyway, the DSL takes care for you to do the actual conversion translation into the right SQL statement according to your database structure.
Got it. Yep.
So that's the way I'm looking at it. First of all, when you have on the client perspective, the information model, you shouldn't have to know that much about the information model. And when we mention AQL, when you need to declare the path, you need to write the path and so on. in my opinion, you shouldn't have to do that at all, in fact, especially, well, unless you have very, very specific use case and so on. But the the distribution of data, it's really, it's kind of graph cloud, a lake. And at one point in time, you just want to extract the information you need for your interpretation, for your evaluation. You want to have, for example, the synthetic view of some vitals combined with treatments, and you want to have that in a chronology over 3 months and so on. You don't need to have all this complex expression regarding the path and so on. You just need to focus on your job, basically. So that's why we need to have a rich DSL, data manipulation language, that makes a lot of abstraction for you, and also a lot of enhancements. For example, I'm sure you've experienced that, but you want to have the allergy, the adverse reaction list for a given patient, right? And you know that when we have that, when we do the query, we have a list as a real list, in fact, right? So we cannot have a vector, an array, giving us a very simplified view on these different adverse reaction. But here, with this DSL, you have that. You can actually have non-scalar fields return into your query expression, and it actually takes care of the formatting for you. So it makes actually the expression of query very, very simple at the end.
Got it. So here we still need to. So I want to come back to the point that the information model is not so important, because if we want to have a unified query language, right? Like let's say that the data manipulation language becomes this unified query language. If you still have to go to another foreign data store and then convert this DSL into a language that store understands, that store still needs to kind of model that information in that very particular way, correct?
That's correct. The thing is, let's say, for example, you have the information coming from extracts coming from from legacy clinical data system that has been developed in-house and so on. Then if you go into the system architecture, you have a query domain here, and the query domain will take care about dealing with views on the specific legacy data to present that to the global query engine, if you want. So you develop that as components, like you would actually do for mapping, but this is not mapping, this is incremental query components that you develop specifically. I want from this data extract from that particular legacy system, and the vitals are actually queried that way. Then actually I encode that as a view. And that view, so it's compiled and everything, I can reference it, and I will integrate that into the query framework with a specific way to access it. And then I will do a union on that with other queries to retrieve the vital for that particular patient across the different components, across the different remote servers.
Got it. No, this is really exciting stuff, and it's quite. It's a unique approach, I would say. Definitely, I mean, if I have to summarize a lot of what we've been discussing, we are moving a lot more of the intelligence into the query domain.
Yes, absolutely.
Got it. And that way,
Yeah.
you can connect to as many different foreign data sources as you want, and you have a different, query compiler for these different query domains, and it finally executes the query onto that destination system, and you get a unified view of the patient's data. Is that right?
Yeah, it's a bit similar. Well, of course, it's really simplified, but it's like a great computing, in fact. You have a different agent distributed on your connected network, whatever is the mean to do that. But what is important, first of all, you know what you want to access, what type of information you access, given this remote node, right? Then you will project it in a way that is actually usable on a global query standpoint. Now, for that, when you do the work at your remote node, okay, that's really the expression. You do that at the remote node. You can test it locally. You can do all sort of manipulation. Then when you're happy with that, yeah, you package it, and then it comes part of the query domain. Because here we have a component-based architecture. It's actually an actor-based architecture. That's another thing actually I'm very keen on dealing with, because my background when I was working in finance is small talk. And
Oh,
small talk, we are not dealing with static objects and so on. We are really dealing with actors. We convey message between actors, behavior, uh, throughout different way to communicate between actors. So it's a very high level of abstraction. Then we orchestrate them. We can do all sort of very nice operation regarding failover, clustering, and so
mhm.
on. It's all dealt with at the actor component framework.
Got it.
So it has a lot of flexibility.
Got it. No, this makes a lot of sense. And just another question, right? So there is this whole paradigm of data engineering, which is around ELT, not ETL, not extract, transform, and load, but ELT, where they load the data into like a data warehousing solution, usually
Yes.
something like Snowflake or now even Postgres, and then they use another, data transformation tool like DBT, for example, right? And they just write a lot of SQL queries to make materialized views, to make different views on this data. And then the final querying is quite simple. Now, I'm just trying to put these two things side by side, right? Like, because if you think about how FHIR has kind of done SQL on FHIR, it's very similar. Like the view definition can be considered like just, okay, you are writing this complex SQL to make a final view that's simpler for the end user to query, right? Whereas this approach,
That's correct.
right, so here the approach is more around the query compiler and making sure that you are able to convert your questions or your domain specific questions into your compiler is taking that and converting it to complex questions, which then runs on the final data source. But I
Yeah,
want to
that's
like
correct.
contrast this with the other way to do this, which is like keeping a copy of the data and like just having materialized views and having this mapping system in the background, which like takes a copy of this data and then simplifies it so that the end user does not need to know about the complexity of the query. All of that is done beforehand, and the end user just does like very simple SQL.
Yeah, that's right. It should be like, I think, in my opinion, that's the way we have a way to industrialize the process to query data, and we have a number of sequences actually regarding the way we architect the data, we package the query, and so on and so on. There is this production work, if you like, in the process. When you do this packaging, of course, you have revision and so on and so on. And then, but on an end user perspective, all that complexity is completely hidden, in fact. So no need to know all that.
Got it. Got it. So are you in the background also, creating a materialized views automatically and like taking care of, I don't know, like I'm just thinking in terms of why should someone use a domain specific language instead of just write a shit ton of SQL, right? Like write so much SQL and then write DBT views and write all of these different transformations, and then finally retrieve the data back with SQL.
Yeah, you could, but there are a lot of issues when you do that. Well, first of all, you have to deal with different data types, for example, or different data type representation. The DSL takes care of that, actually. So you have actually the abstraction. You have other issues when it comes to, in my example, for example, you've seen there is no join. The join is implicit, but sometimes it's explicit, so you can declare it. There are also the big issue of SQL injection.
Oh,
And with this DSL, it prevents you, it has a split in layers that actually prevent to do direct SQL injection, because you address each query on a very specific level of abstraction, and it's stored and so on. So basically, you cannot really perform an legitimate operation on the backend.
got it. Got it. Yeah, I mean, I'm also curious about this ontology resolver that you have, which has this chat GPT icon next to it. Can you talk a little bit more about that?
Yeah, it's a marketing hook. No, I'm kidding. It's it's something that I'm exploring at the moment, is to do some ontology is like a clinical data format. There are really a lot of things, and it's very complicated. And you have external terminologies, you have internal terminologies, and how we reconcile all that, because all we want to know is we want to filter out the data, for example, on symptoms of an hearing loss. And that is actually make things tricky, because if we have different, and some system doesn't use ontology at all, so we need to have somebody, something, an agent that do all the burden, well, I would say the shitty work actually, to go through that and say, well, suggesting what would be actually given this literal, and associate that to a terminology, and then we can resolve that into a transitive closure. And I have some example of lab results from a laboratory in Thailand. So there is a mix of Thai language, there are a mix of English, and now I want to have the line code corresponding to that. And also you have the local terminology for some substance. I want to consider that at an international level and so on. Well, if I have to do that by hand, it's a lot of work, really. So I'm really looking at having some maybe retrieval augmented generation or something, actually, to help us to consolidate, to resolve a terminology code for basic expression, really. It's nothing more than that.
Got it. Got it. Got it. I think that makes a lot of sense. I mean, you could even have a future in which the end user asks for a question more in like natural language, and it figures out
Yeah.
what the
Yeah.
DSL is and like where the different sources are, and it like compiles all that.
Yeah.
Gets the user's
Yeah,
verification
absolutely.
before they kind of like execute it, but it does most of the, what do you say, like the menial labor of getting all the different queries.
Exactly.
Yep.
I think that's where AI is very useful, is to do that exactly, menial work.
Menial. Excellent, excellent. I mean, this has been an excellent, excellent explanation, and thank you so much for going in depth. So, what's exciting for you next? What are you off to do?
Oh, I think I've been asked, there are a lot of codes already existing for this system because as you could see, it's an extensible platform. So I'm working at the moment on the kernel. I have already the DSL, quite a big part of it. There's stuff missing and so on to be added. But I would be very keen on really moving on the proof of concept somewhere. I'm discussing with the guys at Konkan University. They have an interoperability lab that are interested, and I'm working. Well, they're close to my home anyway, so that's very convenient. Also in Bangkok, but actually I'm really open to moving forward to test that, to refine the model, and to adjust it, given in mind that actually keeping in mind that it's flexible, extensible. There are parts, actually, what I'm seeing, there are some parts that should be open source and some other parts that should be part of a marketplace, or maybe you could cut that after during the editing. But basically, my open source experience is quite mixed, in fact. Sure, people are very keen on using open source and so on, but I would say the return and it's not that impressive, and put that really nicely. So I'm thinking that, yeah, sure, some part should definitely be open source, like around openEHR and the storage. Some other, probably they are more commercially oriented. And also there are, that is important, Sidharth, there is a lot of consulting regarding this.
Mm.
You cannot really put that on a floppy disk, I'm kidding, but you cannot put that online and say, okay, off you go, and just deploy it. It's very similar to telco billing system, you know. Telco billing system, I was very surprised. I did that for Orange
Mm.
in Europe, and they bought a very expensive platform called Amdoc from Israel to do the billing. But what I didn't expect at all, they were coming with a lot of consultants to tailor or customize the platform completely, because Orange needs were completely different from Vodafone or another telco company. So at the end, that's really the way I'm looking at it. Yeah, you can do stuff basic. Let's say you want to have to integrate data from wearable and so on, and to have a simple application. But when it comes to hospital, where you have a lot of different information system and you want to federate that, yeah, you definitely need consulting, and that goes very down at the infrastructure level. Then the way people operate, whether they are using Kubernetes or whether they are using one machine, or even though actually it's not contradictory, and so on and so on. And then actually you come here with an extensible system and you do the job really. And I think it gives a lot of security as well for people operating that platform.
Yeah, no, excellent. This is good. So, are you looking at, do you currently have a company, or are you looking at establishing one that can fulfill this consulting needs, or are you working with someone?
Yeah, I'm looking at working with someone, absolutely.
Got it. Got it. That's good. That's, we may have some people listening to this podcast who are interested in your platform, and
Mhm.
they may decide to reach
Uh,
out. Uh,
Yeah,
I'll put a link to your contact down in the description below, so they can just like reach out to you
okay.
if they're interested. Yeah.
Yeah, Cool.
Anything else you would like to tell our listeners?
Yeah, the point is when it comes to I'm very interested also by integration system like that when it comes to more, I would say, it's not NGO at all. For example, in Thailand, we have a network of rural doctors distributed into the country. There are a lot of needs actually in terms of healthcare, of course, and I think this kind of platform could suit very well this problematic, gathering data and if you think, for example, in tropical countries, of course, we have all these issues regarding tropical disease and so on, but also regarding malaria and so on. We can do a lot of things around that.
Excellent. So NGOs and for-profit organizations, whoever is interested, reach out, Christian Chevrolet, and I will put a link to your description. Did I pronounce your second name right?
Sorry?
Did I get your second name right?
Christian
Chevrolet. Okay, fine.
Yeah.
Fine. Great. So excellent. Thanks again for taking the time today. It was a very detailed one, and I'm personally really interested in this newer approach, right? I think it's also important to not just stick to what we know and also go beyond and see different ways to do things, especially as database technology is getting better, AI is getting better. We don't know where we are going, so it's good to amazing work, by the way. And I think I'll put your link as well if you have other resources, maybe a paper or just a white paper I think you had. I'll put a link to that as well down below. And excellent. Thank you.
Yeah, thank you, Sidharth. It was a real pleasure talking to you. Yeah.